8, and then we'll just start it. So we won't be like sitting here do nothing until 8. Okay, 8 is the latest. They'll go, we will not, probably will not do that. The exam is time limited, right? Meaning that, like, okay, I release it at 7:45. You're not, if you didn't go in at exactly 7:45, you're fine. Okay, don't be like, oh my god, I'm missing any minute. Counting down whenever you start. It does have a limit on the end date, on the end time at 9 p.m. Right? So if you start anything like after 9 or 9:30, after 7:50, you will have less than 70 minutes. Does that make sense? Right? Time limited also have a deadline of like, this is the latest you can submit. So both come into effect. This week and the following 2 weeks will all be on classes, meaning that there will be no quiz. Okay? We'll have 1 quiz for classes, and that will be out 3 weeks from now. So don't worry about like, oh, I'm going to do a quiz. I'm also going to do project 2. Don't worry about that. We will finish all the classes, and then we'll have 1 quiz, and that will be the quiz on classes. Yeah? Yes?
So will the content of this lecture won't be covered in this?
It will not be. So midterm cover everything up until last week, templates, right? From classes, this is officially the start of the second half of this C++. All right, and I mentioned this before. Ever since classes, it's gonna start to get really hard. Slides will become shorter and shorter. Does not mean it's gonna get easier. It's just that we are trying to scope how much new concepts you're learning each week, so that you have time to digest it, because the following week depends on that week. So you really need to make sure you catch up on every single week. Otherwise, you miss 1 week, you're like, what is she talking about? Because I'm talking about things based on the understanding of the previous week. All right. Classes is what makes C++ really interesting and really, really powerful. Okay. We mentioned this concept the first week of the class, where we said, oh, like object-oriented programming is what makes is what C++ support, and then the foundation of object-oriented programming is object. It's in the name. What makes object? It's class. So what is a class? We show exactly this, right? Back then, where we said we can have a class that is a car. It has attributes and behaviors. Attributes basically are variables, and behaviors are functions. Okay? So when we have a class car, you have, this is the name, right? Attributes, we're going to talk about public, and functions. Those are different than other variables or other functions that you have seen so far, because all of the things that we define in a class can only be triggered under the class. Okay? So you cannot be like, I'm going to call a function start. It's going to be undefined. We don't have a function start. We have a function car start. That's the function, right? So the class functions are different than regular function. The class function is only inside that class. You can only trigger it from the class. Similar to the attributes. You don't have a color out there. In your main, it'd be like, color equal to 5, what's color? There's no color, you have car color. Right? That's the difference between class attribute functions versus regular variables and regular functions. So let's talk about types. For some programming languages, we have a difference between what we call a built-in types, like integer, float, double, or long, right? Versus user-defined types, right? Say car, right? For C++, they're the same. Remember when we talk about templates, I show you 2 different syntax do exactly the same thing when you use template for type and template for class. The reason they're the same because C++ does not distinguish them, right? The car class that we were just showing you for C++ is the same as it. Same as float. They're just a class, they are a type. So in C++, type equal to class, right? When we say, oh, my car is a class, car is also a type in C++. Therefore, when you're defining a class, you really want to keep in mind that, oh, what's required for a type? The amount of memory required, right, for a type is very necessary. When we put an integer, your computer needs to know, oh, this is an integer, so that I give you like 4 bytes here or 8 bytes here, right? Similarly, for your class, we're going to show you how your computer recognizes how much memory your type is going to need. Layout of the memory, what to store and where, right? Like in each of the class, we have more than one variable, right? If it's an integer, you have one variable, 8 bytes, that's it. A class, you can have multiple. You can have an int, you can have a float, have a string in there. Then we need to define those so that your compiler knows, oh, okay, we need to store this much in this class. The operator used to modify the object, we're going to talk about that later today. Member functions, right? We talk about that as the behavior that you use. So you see that I specifically say member functions, not just functions, right? Those are different. Attributes instead of variables, right? Attributes basically variables of a class. Attributes and whether or not and how to copy and move the object, etc. So everything that you will need for a type, you probably need for a class. Okay. Defining a class. So this is pretty obvious on the syntax, right? Class with lowercase, you actually have it color-coded showing that we're defining a class. The name, go right after it. Everything inside the class should be wrapped by curly bracket, right? So everything is in there that belongs to the class. And then you can have variables, and then you can have functions. For variables, we call them class attributes. That tells your compiler how much memory it needs to start with. We don't know how much memory the function will take. However, if you define that your car class needs a string, a float, and an int, we need at least that much to store your class. For functions, that is class methods or member methods that specify the operations or the behavior your class could have. Okay? When we talked about this, class function can only be triggered from a class, not any class. When we're defining a class, we actually have two parts: interface, implementation. We talk about this for function, right? We can declare a function, and we can define a function. Declare a function, just tell your compiler what that function is. Implementation, tell your compiler what that function does, right? Similarly, for a class, you have interface and implementation. They are no longer optional. Required for a class to have both. Functions, optional, right? When we talk about function, you could have function declaration at the beginning of your main, you trigger it, and then you have the definition. You don't need to. You can just put your function definition at the top, which is what most of you do. It's fine, right? For a class, not an option. You have to have interface, followed by implementation. Okay, you have to have both. Let's look at different. So this is a complete example of a simple class called student. So we're going to start at the top, which is the part that we went over with car, where this is a class called student. You have noticed that the first letter of a class, we try to capitalize it. That's something that we do for C++, right? Whenever you have a class, we have the first letter capitalized, and then that's the name of the class. This class is named student. Attributes, we have name, which is string. We have 3 floats, test1, test2, and test3, right? Functions, we have average function that will return a float, grade function that will return a string. Pretty straightforward? Yeah? This is the interface. When you have the interface and the implementation together, you need this semicolon. Okay, so make sure you have that. But after today, you will know that we will try not to have them in the same file. All right, so the top part, interface, you need to have that. And then implementation. And the way that you implement class functions, you have to tell your compiler those are class functions, right? So you have to have student scope operator, 2 columns, function name. If you don't have that, you are defining another function. Function average is completely different than student average. Okay, two functions. If you define an average, will this run fine? Yeah, it will run fine. Can I run average on the student? No, you cannot. It's not defined. Right? You just define another function. When you run your code, when you write your code, everything will be fine. No arrow, no marking. When you run it, you'll be like, why can I not run? Make sure that all the class functions are actually defined with the class name, so your compiler can match them. Other than that, everything else the same, right? You just have a regular function, you put your code in there. Similar here, when you have a function, you just put your code, and then if you return it, if you return a string, make sure you return a string. Okay? One thing that's a little different from the implementation, notice here, I'm using test 1, test 2, test 3 without defining them. How does your compiler know where test 1, test 2, test 3? It's exactly because you have student. This does not just tell your compiler, I'm defining an average function of student. It also tells the ownership, meaning that, oh, you're defining something for student, you should be able to access everything inside student. A class function should be able to access everything inside a class, including variables and other functions. Okay? Similar here at grade, right? You see that when I trigger a function under the same class, I also do student average. This is just not to confuse another function that's out there that's not under student called average, because that could happen, right? It will not error out. You could totally have two functions, one called average, one called student average. So this is just me trying to show you that, oh, I am calling the function average from inside the student. Is this required? No. Similar to up here, right? I could have student column test 1 plus student column test 2 plus student column test 3. I can do that. Do I have to? No. So how are your compiler going to look them up? Your compiler actually will look it up from the class first. So if I remove this student, it's actually going to be fine, because the minute that you tell your compiler, oh, I'm defining a function grade in student, when you're calling like variables and function, it will try to find it in student first. Okay? All right, so let's put that on the top interface or declare a student class with the name of the student and the test scores. The student class is two function, right? That's what you have in your interface. Implementation is down here. We declare how those functions work. Yeah? Oh, I have animation. Perfect. Yes. Great. All right, let's focus on class interface. Why do we need that, right? And why is that required? We use class declaration to define the existence of a class. The reason that is important is because both compiler and programmers read it. Your compiler use declaration to understand memory allocation for the class. It does not need the implementation to do that. All your class attributes are defined in the class interface. All your class function and their return types are defined in the class interface. That's all the compiler needs to declare that, oh, okay, you have a class named student. And then after that, you can use student, right? Programmers, we're going to show very soon after this that we don't normally put them together. We completely separate them. After today, you can actually go and read outsource or open source C++ project files, and you will understand them, because they will always have, they will start with a source folder. Within there's all their code, and they will have a header file folder. Inside there, all the file has .h or .hpp as extension. That's specifically for header file, which is stored interface and interface only. And you wonder why, right? Why do we split them? Because the definition could be thousands line long. If I want to use other software's code, I want to use the class student, right? Do I need to really understand how the average is calculated if I already said that it's going to calculate average? right? Do I really need to know how the grade is implemented, given that it's that grade there? It returns a string, like I know what that means, right? If it's not clear enough, you probably have noticed that in the interface, in the declaration, I have detailed documentation, but I have less of that in the C++. This already shows you my habit, right? We try to document a lot more in the header file, because that's what people read. They look at the header file, right? Colleagues come in, look at the header file. They yell at me if I don't have documentation. If I, do not document some of my source file because I'm lazy, less likely people are gonna yell at me. Right? Because they will just go to my header file and be like, oh, okay, Jen wrote this. I can use this in this way. This return that. Got it. Right? So that's also another reason that we split them. How do we split them? Okay, so here's talk about the compiler, right? Detail of the compiler, how they use it. The compiler will look at, okay, you have a student class. You have one string. You have 3 floats. You're gonna grab the memory so that it's enough to store all of them, right? And that's it. That's good enough for a compiler. Let's look at programmer. Programmers come in, be like, okay, you have a class student. What can this student object, this student class do? Oh, it has a name. It has 3 test scores. Perfect. And I can call function average and I can call function grade to get the average of 3 tests, read it in the comment, and get the grade, letter grade based on the 3 tests. Very clear. With that, you can call this, right? You can go and trigger this class, you can call the function, you can use it. Now let's see how we split it. Okay. So we saw this example. We have the top part, interface, bottom part, implementation. Can I put them in the same file? Yes. Actually, for your next project, I will ask you to put them in the same file. Right? I will not have you worry about splitting them just yet, so that you can focus on just class, like because it's actually easier when you first started to see the interface and the implementation at the same time, right? You'd be like, okay, I'm implementing this, you do that, and then next you're implementing that, you do that. So for the next project, I'm gonna ask you to put them all in the same file, so this will run. This is completely fine, okay? The extra credit, after that, I'm gonna start asking you to split them. Also for the project after that, I'm gonna ask you to start splitting. But the first one that we're gonna ask you to write classes, I'm gonna just have you put them in the same file. So this works, alright? But if you want to split them, how to? Neo5 extension now student.h or student.hpp. .h is more common. So when you submit it later on in the project, I'm gonna expect you to do .h. And .cpp. So you will have a file structure looks like this. You will still have your main. Main should be separated from any other things, right? Again, it's not for the next one, right? Everything is going to be in the same file. But when we separate them, for each class, you will have student.h, header file, student.cpp, source file, together that define one class. Your main and your regular functions, right, are all inside main. Please don't have your regular function inside a random class if they do not belong to those classes, right? That's where I will be looking for your function. You're gonna submit more than 10 files for your final project. I may not be able to find it. If you put it, be like, oh, I'm just gonna randomly put it in this one file. I don't know what I can find. Okay, so when you have regular functions that does not belong to any class, put them in main. Main.c++ is where you put them. Okay. Now let's try to move it. We're gonna take the first portion of our previous example, which is here, to its file, to the separate file. So everything between 12 and 22 is actually the same. Now, in addition, you need more stuff in the header file. You can't just move it and call it a day. Okay? So what do we need? The red, yellow? Yep. Yellow. The yellow boxes are the things that we need for header file and header file only. That is to help your compiler to not redefine something that has already been defined. Let's read this. It's actually readable. If not define, define, and if. Okay, so very easy to remember. So if and for not, then for define. So if not define this term, so you can think of this unique identifier. That's why it's all capped, right? Because it's not a variable, it's not a class. It's what we call unique identifier for this class. If not defined, please define it. And if. Very important to have an if. And it's very small at the end of the file, very easy to forget, but your file will not come out. It will not come out if you don't have this, okay? Once you have that, meaning that if you include, I'm going to talk about include the next slide, that if you include this multiple times, you will not have multiple student headers. You only have one. You'll get defined once and once only because you safeguarded it. Okay? So that's the red, the yellow boxes. The yellow boxes. If not defined, define, and then. Okay, have to have them all. Between them, you can have your include statement, a namespace, all the regular things you will have for your main. Now, what do we include here? Things that you will be using in here. That's all. I have used string, therefore I include string. If I don't use it here, but I have used in the definition of a grade, that's another file, don't worry about it. So just focus on what's inside the interface. If you use a string, include a string. If you use like CMath, sure, do that. If you use something else, do it. If they're not in here and that they're in the definition, don't worry about it. Because in the definition, you have your own include statement. This is the definition of student class. We moved everything from 11 down to 24 over as is. Didn't touch anything. We added using namespace std. At the top, you have to include a header file. Now, okay, when we include a header file, I could have 5 classes. Similarly, when you need to use a term that your compiler does not recognize, if you're defining a function of a student, you need to have this. You're coming to be like, what is student? Like, I don't understand. If you include the declaration, the interface of student, your compiler's good to go. You're like, oh, that is the student. Yeah? Now you see the class student.h has no different than type string. Right? The only difference is how you include it. If it's something that you define, you put it in double quotes. Make sure you have exactly the file name. If you have .hpp, you have to have .hpp. Right? For already defined class, you just do it in the bracket. You don't need the file name. Yeah, that's the only difference. Use the same include statement. Use the same thing. All right? Yes.
Sorry, I'm a little bit confused by the capital letters there when we in the previous.
In the previous.
Yeah. When we define, we're using capital letters. Is that like requirement or?
It's really not. It's just a habit, right? People try to distinguish it between like a variable, distinguish it between a class name. It's a habit for people to.
I mean,
use it all
in
times.
the yellow rectangle, there students underscore age.
Those H is so that we only have this for header file and remind us this is not CPP. Not required. You can have S,
Yeah. Okay.
but like, will S be defined somewhere else? Probably,
Yeah.
right? So you want it to be as unique as possible. So it's very common that you use the class name underscore H, so that this is the declaration or the interface for student.
But if you use lowercase, would that work? Or
Probably
just
will
that
work, as long as it doesn't have a conflict.
Okay.
For student underscore H, probably.
Just good habit, yeah.
Yeah, it's a good habit to distinguish the type. Yeah.
We have to use underscore, right? It's just how it is.
No, you can use whatever. But like that is how. No.
Makes sense.
Another thing, the reason that we have that safeguard is that you're gonna see include student.h everywhere. We're gonna have it here, we're gonna have it in main. When you have 11 files, it's gonna be in 5 of the 11 files. Every time it includes that, it's gonna try to define it. Right? It's gonna try to be like, oh, what student? Oh, is that defined? If you don't have that, if not defined, define, it probably will define it again. Okay, so that is also the reason why we have the safe harbor definition. Any other question? Yeah.
Since when did actually it become mandatory to define the class of the interfaces only? Is it like an addition or?
No. So notice that if you don't have an interface for the class, there's nowhere you even define the attributes. The definition only have functions.
A question, it used to be actually like you would define your class and you would actually implement your functions inside the class without any issues.
You can still do that. I'm gonna tell you that you can still do that later on. Not a good habit. No, people are gonna hate it, right? When you work in group, people be like, why do I have a header file that's like 100 lines long, right? Like breaking into 2 or breaking into 3. Who are your definition out there, right? One thing that you're gonna do when you're going to industry is that your code needs to be reviewed before it go anywhere. You just not be like, oh, I write this, submit it to the deployment and it breaks everything. That's not gonna how it works, right? Most people are gonna review your code. The first thing they're gonna ask you is what type of implementation in your header file, right? Because people don't like that. But if my implementation is this long, no one's gonna yell at me, right? But if my implementation is 100 lines of long, no, right? That's why I start teaching it this way first, and then yes, I will release it. I'll relax it later on in the class when you get more familiar with this. So that you, at the beginning, you already start developing this good habit. It's not like I'm trying to correct it later on.
I mean, I'm
Yes,
asking
you
because.
can.
Sorry.
You can, yes.
Sorry, I didn't mean to. You done?
Yeah.
Okay, and the reason I'm asking is because I saw this behavior in Java. And I'm wondering if C++ took after Java or Java took after C++.
No, it's different. They're very different languages. It's fine with any other language how you want to structure your code. It's more kind of a common thing between programs. Not something that C++, like you cannot do this. As a programming language, it will try to give as much freedom to software engineers. Whatever language the software engineer want to use, however they want to use it, right? If you go to Hackathon, you will see their code looks completely different than how I'm teaching you right now. Because they're optimizing for speed, writing speed, running speed. Their variable's not going to be single letter. It will not be readable at all, but they can write that in hours and run it and win, right? That's not how we do that when you get off Hackathon, right? So like the way I'm teaching right now is more like an industry standard, kind of. But not like, it's not saying that you have to do it this way. Since you brought it up, I'd be like, yeah, you can. Try not to do it. We will relax it later on in the class. But for now, let's split them cleanly. Okay, let's split them completely. Alright, so here I'm showing you how someone else come in and use your code. For us to write main, on the right hand side is your main, right? That the first thing I need to include student.h because in this file I'm using student. That's why I need to include it. Then I need string, I need outstream because I probably have output somewhere. Those you know, right? The library you use in the file you include them. Everything else the same. Now for people to use student to write a reasonable main, all they need is your interface, right? With that, we create a variable of type student. You see the way that we define it is just as int I, yeah? Float f, double d, student s. No different. This is a type. C++ does not think there's any different than string or int or float. So for you to use that, you use it as a type. Think of it as a type. This is capital S type, right? Because you defined it. This is student as this is the object. This is the type. Okay? So I'm going to start to use another terminology, object now. Class is what you use to template type or define the blueprint of objects. I can have student as 0, student as 1, student as 2, student S99. Those are all the objects being created under the same class. Yeah? When we are calling those variables, you have to do S dot. There's no name, no test 1, test 2, test 3. It has S dot name, S dot test 1, S dot test 2, and S dot grade. Okay? Yes?
Would the inbuilt types also be considered objects? Like if I did int x, would that x be an object as well?
It is.
Okay.
So everything is object in C++. So int x, x an object, type int. Student as an object, type student. However, the built-in types like int, they're really small. You don't have a bunch of variables that you need to allocate memory for. But remember when we were doing cin and cout and even int or something, an array, right? We can have something, remember array.size or something like that, right? Those functions are defined in that class of int. But it's already defined by someone else inside the library, so we don't need to define it, right? Array is a type, it's also a class. The size of function of the array is defined in the class of the array. So yes, those are all types, those are all classes, and those are all objects. Correct.
Like
Yes?
you can say like, for example, student one and then like one dot name like that.
Yeah, it's student S1. You cannot have a variable start with a number.
Number.
Yeah, so S1, then yeah, you will have S1.name, S1.test1, S1.test2. Those can be completely different than S. Two different objects, two copies. Yeah? Yeah.
If we're in main, is student as recognized within like loops, or do you have to define it within a loop?
Good question. Similar as any other variable, right? If you create that inside a loop, it only exists inside that loop. So every time that loop runs, it's going to create this object, use it. When you jump out of that loop, it's gone. So if that loop goes again, it will be recreated. Exactly this. So similar as integer. However, whenever you use those in your loop, same thing. Right? Same thing. All right. Any question on that? Yes.
Is C++ a case-sensitive language?
It's not. But for class though, right? You need to have capital S. Variables, I don't have it here, but you have seen me use like capital in the variable names I have to define, right? Function name isn't, yeah, it's not. Right? I can have like average grade with a capital G, right? That's completely fine. I can have, I don't know, test with a capital T if I want one. Yeah, I can have capital or this is just for class. And then the previous like all cap one is just how people like use it. Like,
So it's all by convention that you were doing these things, including class?
not for this though.
Oh, okay.
But like yeah, for variable like you can have some capital letter here, that's fine. It's not restricted usage for class. You can have variable with capital letter, you can have function with capital letters. You can do that. But if you have a function with a capital first letter, will it run? It will run. Will that be confusing? Oh yeah, absolutely confusing. People look at that and be like, is this a class? Wait, it's not a class. Wait, why is there parentheses after that? You know, like, just that. All right. Let's look at the full picture. We have main over here. We have student.c++ over here, right? Let's look at the include statement. I talked about it in the previous slide, but let's look at this. Where do we need to include? Student.h is the place where you define student as a type. Without that, your compiler does not know what is student. So wherever you want to use student, you better have that, no matter which file, right? In here, you need that. In here, you need that. And then you're going to ask me, well, in that case, I'm just including it everywhere. Remember, every time it's being included, your compiler is going to go and check, and when it's defined, it's going to significantly slow down your code. Another thing is, please do not create a loop. What do I mean a loop? I include student.h in my main.cpp, right? This is my main.cpp file. And then inside my student.h, I decided to include main. Yeah, you're not gonna run, it's not gonna run. That's a loop, right? You're including something inside another something, and then you really try to include each other all the time, and it will run. So don't do that, but if you follow the rule that you only include the things that you need to use, you should never include main. Like, why would you include main, right? But you will include other classes. For example, I have another class called Cont.h. My student, say here, needs to use a count somehow. Then yeah, I will include student.h in this, I will include a count.h in the student.h. Please don't do it the other way around at the same time. Okay? If you in a scenario where you absolutely need to have class A include class B, at the same time class B include class A, you have a design problem. It should never happen, right? Meaning that there are things in those two classes that do not belong to those classes. You may need a class C, you may need a class D. That's where your engineering comes in, right? You need to design your code. It's not just you just write whatever I tell you to. You need to think about it. But for this class, I also tell you what to write, so you just write what I tell you to. So you will never run into that. But in the future, if you run into that, you're like, oh, maybe I should not. I should think about how I'm structuring my code. Yeah, so that's include. Okay. Another thing is, you have noticed, I never include student.cpp. That will also create a loop. Because student.cpp for sure includes student.h. In here, some people will be like, I'm going to include student.h. I'm also going to include student.cpp just in case. No, you do not need student.cpp because everything inside student.cpp should already be in student.h. Okay, your file will give you a very weird, very long, uninterpretable error. You're going to take a screenshot and send to me, and I'll be like, please send your include statement, I include it. Okay? Alright, so now we have a broad understanding of what's a class. Remember we have this namespace that we talked about also as a place to house names. Like, okay, what's the difference between those? Those two are both called scopes, but they're completely different. Namespace is just a name containers. It contains names. Nothing to do with object, nothing to do with types, nothing at all. It's just thinking of a folder with names in there to avoid conflict of another folder with other names in there. That's all. In the namespace, you can have functions, you can have classes, you can have whatever you want. Class, though, are the foundation of object, right? You use class to define your objects. If you don't have a class, you don't have objects. And someone else already asked, are int a class? Yes, they are, right? Class types, all the same in C++. Yeah? Okay. Optional information. Some of you be like, oh, you talk about namespace and you only show us how to use std. What if I want to create one? Actually pretty common in the industry that we create our own namespace, right? This is just to show you how to. You will not be using this in class. For this class, you will all be using std or iOS, right? The things I tell you about, you will only be using those. And you will not be defining a new namespace. Either for this class, you will define your names, your classes all inside std. They're all going to be in the same namespace. By the way, talking about that, I forgot to mention, using namespace std are no longer optional. When you're creating class, the using namespace std is no longer only used for you to call function in std. I'm going to. It's no longer for you to just be like, oh, I can use stdcn. Like, no. It's also telling your compiler your definition of student.h is inside std, so that you can call it. Because if you don't have a namespace, they could be in some other namespaces, and the compiler will not be able to find it. So please, please, please have using namespace std for your classes. All right, no longer optional. All right, let's go back to here. Yeah, so with that, then you will know that for this class, we will define everything inside STD because we will always have using namespace STD in all of your class declaration, right? And declaration, right? That's where we declare. Yeah. All right, you've seen public for the longest time. What it is. So there are 3 different access specifiers for a class. Public, private, protected. What do they mean? Public, meaning that not only your class has access to those function and variable, anyone else can do that. Any other class, any other functions, main, can all access your functions, can all access your variable. Completely public. Private, which is actually the default. Okay, the reason that you saw me putting public there is that if I don't put it, it's private, my main will not be able to run it. Private is that only the class itself can see it, change it, and modify it. Completely private. There's a middle layer called protected that it will not make sense for now because we have not talked about something called derived classes. But protected is that only a certain type of classes can access those. So it's the middle layer. So we'll talk more about protected later. Let's look at this private. I tend not to omit private. I try to always have private. Do I have to? No, because it's default. So if you don't have that, you'll work completely fine. But then you need to be very careful on what you put right in front of public. The spacing becomes important now, which I do not like. So I normally will always have private to declare, okay, those are absolutely private, and then I will have public, but you always need public if you want public to know what's public. Also, I like the way that it lines up better, my preference. And this is how you can have private and public in your class. The reason, say that I want private for this, is that those are test scores for students. Do I really want anyone to see them, anyone to modify them, that you can just come to me and be like, my name dot test1 equals 100. Well, actually, for int I from 0 to 3, all my tests equal to 100. Not so safe, right? You probably would like that. Not so safe for me, right? So I want that to be private, meaning that I control how those tests can be accessed. Does that mean that I'm not giving access to anything? No, I can still give out access, but I can give out to specific people that I think are safe to, right? Average. This will complete the average of 3 tests, which will return a test score, right? Be like, that's private information, right? If you cannot modify test score, you can just take your average and be like 100. No, right? So I decided to put them all private because I'm defining a class student. You can see where that's design logic, right? Nothing about like, oh, those variables now have to be private. This is engineering now. This is a decision that you make when you design your class. You decide what's safe to be private, what should be protected, what have to be public, right? You make that decision as a software engineer. That's where the engineer comes. Software has to be software. You're being programmed, right? You write, what I tell you to. Now this is like design decisions, like when do I do private, when do I do public? For the names and grade, I decided to have them public so that it can be accessible, and let's see how my main need to be changed now. Test 1, test 2, test 3 are now all private, right? Meaning that inside main, you know, this is my main.cpp file, so inside my main, this is my main function, which was blocked. If I do s, I created an s object, remember? The same code. I took a screenshot of the arrow. S.test1, no longer accessible. Yeah? Because this is private to this class only. Your main, you should not be able to access this. Right? Similar to test 2, similar to test 3. So your compiler will actually tell you, your IDE will tell you. Don't rely too much on it. Remember, the minute I transfer, I suffered because you are not allowed to use IDE. You will not have those nicer, you're like, oh, you have to fix this before you run. If after you transfer, your school does not allow you to use this, you're on your own. okay? But now, you can use this. So cool, we can calculate it a little bit and be like, oh yeah, those are private, I should not be including them. Now, because it's private, cannot have access to test 1, test 2, test 3. Well, how do I set it up? Like, everything by default is a random number. How do I input, right, my student scores then? There's a way. I'm going to talk to you about mutators and accessors. It's in the name, mutators for write, accessor for read, right? Two functions, setters and getters. That's how we call it. Because the function is only responsible, too small, huh? The function should only be responsible for setting. Setting meaning that writing, right? Writing this variable. We tend to have it start with set. To be like, this is a setter. Can I have other function name? Of course, of course. Will this be more readable and commonly understood by other programmer? Absolutely. Yeah, if you do set, we know, oh, it's setter. Okay? So when we do setter, we can have capital letter. I don't know who asked, but yeah, we can have capital letter here. That's fine. So we set task score, and then I will take in the task scores as inside the parameters. Right? So whatever got fitted into my function, I will set it. It will look something like this. I have more control. Is this big enough? Do I need to zoom in? Inside my setter, I can have more granular control. I can say, if I'm going to have another variable called access row is admin, right? I'm going to run this. Meaning that I'm going to assign the variables to the class member. Otherwise, you don't have access to alter a student's score. Yeah? Can I have more complicated logic inside the setter? Absolutely. In nowadays, settings, setters and getter, we're going to talk about getter, right? One control read, one control write have the most complex logic because that involves security in there, right? If you open up something for people to write, say that your password, right? Like websites start to be like, oh yeah, anyone can access to this. Probably not so good, right? So most of the time, the setter and getter have like super complicated logic. If you are under this license, you have this user, sure you can do that. Otherwise, no, right? So yeah, you can have a lot of complicated things in there, but this is just an example that I can have more granular control on how and who can write. Yeah. Oh. Now, just to demo, right? For a access row with member, for example, you will be able to get the alert message that is assigned for you. If you have an access row of admin, then it will run fine, right? It's a function with each statement, very simple. Right? Let's look at getters. Also, we call get functions or accessor to be more formal, but we call it getters. Similarly, we start them with get, right? Can you start with something else? Of course. But normally people start with set and get. You have noticed the difference. Setters always void. You're not supposed to return anything when you're only trying to write. Getters should not be void. Because when you're trying to read, you're supposed to return to other people what they're trying to read. You have to return something, right? So that's pretty common that you have void for all the setters and whatever type you're trying to return for the getters. And again, you can have more granular control on who to read, right? You can give read access to specific people, otherwise no access to average score. Yeah? You see that I am still trying to return a float. Remember those 404 arrows that we see, 505? Those are common arrow code that people return when they reach a specific arrows. For internet, it's a little bit different, but It's a similar idea, right? You return something indicate that there's an error. Pretty common. Yeah, so example of how to run this. If I have an asset from admin, I should be able to set, but I will not be able to get for guess. Right, so if I guess row, I will be able to pass that if statement that I just designed in my getters. So that's controlling read access. All right. So this is how we can have access, write access to admin, right? And admin can also like read as well. All right, that's it for today. We talk about class. We talk about variable functions. Functions including mutator, accessors, setter, and getters. Class interface, implementation, header file, include statement, the difference between the two, the first two of the SS specifier, because we will talk about protected later on. By now, you should be able to fully understand any C++ repository structure. So if you want to be like, oh, can I hack this? Probably not, but at least you can read it. Right? You need to understand your code before you do something about it. Right? This gives you read access, basically. You will go in there and be like, oh, what are all those .h files? Those are header files. You read them, you understand what they do. If you be like, oh, I'm very curious how you implement this function, sure, you trace down to C++ file, go to find that function, you need to see the definition. That's how we structure our code for C++. Right? You have a question? Somebody else? Yeah?
Yeah, can you use private functions that's part of a class in the main CPP?
Can we use what?
A private function declared in the class as a student, and I have object S, could I like call that function in the main?
Inside the main now. Similar to variable, if it's private, you cannot access it outside of that class.
So only in the class?
Only in the class,
Okay.
exactly. Only in the private is private to the class. Only inside the class can access it. Anything else, any other thing, right? You create an object, no. Yeah, sure you can create an object, you cannot access the private. It belongs to that object. But yes, very important to understand the difference between public, private, and later on protected. We will abuse this a bit in the later on of this class. We will abuse like, oh, we do this, let's make it public. We do this, let's make it private. This is very commonly used to help you design your software. Yes, question?
Will we be able to check our answers, the answers that we got wrong after the test?
The quiz? Oh, the exam, the midterm? We're going to what, check?
Yeah, like once we submit it and we get our score back, can we check what we got wrong?
After you finish everything, or after you finish one question?
No, the exam.
Will you be able to finish?
After you finish the exam, you can see there's sometimes, like, when you're finishing the quizzes, it says, like, what it's, like, false, and then you can just see these things.
Oh, you
But
can
after
do,
submitting it.
you can do that while everyone's taking the exam. But you can do that after everything is closed.
After 9,
Yeah, after 9, you should be able to do it.
Oh, so it will like show up after 9.
Yeah, you won't be able to see it. I mean, yes, you have one attempts, but like, yeah, you won't be able to see it at the spot.
I
Is
know
that
what
what
you
you're
mean,
asking?
like it's released at 9.
It released after everything is finished. Yeah, it should
Right.
be automatically released. And you
Alright.
should be able to just go ahead and say, oh, I got those. Yeah. Oh, yeah.
When are you releasing the extra credit?
After this project. After, we're at project 2, right?
yeah.
After project 3.
Alright.
Between 3 and 4. Because 3 is where I asked you to write everything inside. Wait, hold on. Between 2 and 3?
I checked the syllabus and it said between 2 and 3.
Between 2 and 3? Okay, then between 2 and 3. Yeah. Between 2 and 3. So after 2 is due, I'm going to release it. It's going to be a 1 week. You do it or not. Within that week, you cannot do late. Right? If you miss that, you won't be able to do late. After the actual credit that week, you won't be able to do actual credit for project, which worth a lot, right? You can still do quizzes that were 3% total. If you do both, you get 8% boost. Very great. All right. Any other questions? Yes?
Regarding that, this is I'm not sure if I misheard you or I misinterpreted your words. You said actually if you create a loop between the header class and the main file.
Header file and the, yeah, you could.
I think that I heard you said it would break your code.
Yeah.
Would it actually break your code?
Yeah, it would, but you would never include main. What happened that most people do the loop is that when they have multiple classes, try to include each other. You're going to have A include B, B include A, and that's a loop. And yes, you will get an error when you run it, say like something about linkage, something that does not make sense. It will not tell you that you have a loop. No. It's something that's unreadable. But I've seen it so many times, it'd be like, oh, you have a loop. Yeah.
That's very interesting to know.
Yeah. It's a loop. It won't do that because every time you include something, your compiler is going to try to interpret it, go for it. And if you have a loop, it's just going to keep doing that. And actually, the compiler not recognize that when there's loop, they just break it right away to safeguard the